Yeah, good morning.
Good morning, sir. Welcome.
Good morning. I'll just present my screen. Just let me know that whether it is to you. Yeah. Is my screen visible? Is presentation visible now?
Yes, sir.
My screen visible. Yeah. I'll just play the video also once. Hello. Yeah, there is one just video illustrating video. I'll play that. If it is working fine, if you are able to listen to the audio, just confirm that.
Hey, baby. Hey. To create avatars that can actually learn, interpret, and interact with the world around them, like a real.
Are you able to listen to the noise audio? The video audio, I'm asking. Okay. But otherwise, you are able to listen to the audio, right? Okay, thank you. Then I'll join at 10:55 then. Is that okay? I'll be here only. Please let me know when to start.
Sure, sir.
If you have to be fair, then be fair with me also.
Good morning, everyone.
Good morning, sir.
Good morning, sir.
Hello.
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 Yeah. Good morning.
Good morning to you.
Yeah. Good morning.
Good morning, sir.
Good morning.
Harsh? Harsh? Harsh, are you there? Harsh?
Hello.
Yeah, are you there?
Yes, sir.
Yeah, just check it out with the presentation of Dattatreyudu if it is working or not. Just check. Sharing the screen.
Definitely, sir.
Yeah. Okay, okay, cool. Yeah.
So the demonstration has been done.
Okay, okay.
We'll wait for a few more minutes till the participants join.
Yeah, yeah, that's fine, that's fine.
Yeah, good morning, all.
Good morning, sir. How are you?
Yeah, I'm fine.
Yes, sir. Amin here, this side.
Oh, yeah, good morning, Amin.
Yeah, good morning, sir.
Shall we wait for 5 more minutes?
We can start. I guess people are joining, so we can start with the. We can start. Harsh, you can start.
Yes, sir.
Thank you very much. Thanks for the introduction. I'm sharing my screen. You just please confirm once it is visible. Is my screen visible?
Yes, sir.
Is it visible now?
Yes, sir.
Yeah. Very good morning, all. Today I'm here to share my experience working in the domain of artificial intelligence and machine learning and the application of these techniques to our engineering use cases. This is the flow of my presentation. I'll start with I don't know the audience background, so I'll try to introduce the machine learning, the definition, broad types, popular techniques in machine learning, and the applications, and how do you evaluate the machine learning algorithms which we develop, and some important issues. After that, I'll share the engineering use cases which we actually applied these machine learning techniques. If you see, according to Tom Mitchell, that the formal definition of machine learning is a computer program is set to learn from experience with respect to some class of task and performance measure. If the performance at a certain task is measured by is improving with experience, then that is called machine learning. The examples are classification, acting in an environment. And what is experience? Experience is the data what we have, the past data and the background information. Okay. And what is the measure of performance? That if that whatever performance or whatever the prediction which we are doing, if it is increasing with some experience, then that is a measure of performance. If you see from an normal definition, that how it is different from an algorithmic solution, that in algorithmic solution, that we have data and we have program and we get the output. Whereas in machine learning, we have data and we have the corresponding output of that one, which we give to the algorithm, which will give us a model. Then here, the output is a model. And machine learning, which explores the data and it learns from the data and builds a model. Okay. Stop me in between if you want, if you are not if I'm going fast. Okay. And here one thing which we need to keep in mind is like no machine learning algorithm is like fixed to a particular given problem. We need to apply different techniques, and based on its performance, we need to choose the best algorithm. These are the broad types of machine learning algorithm. Machine learning that is supervised, that for every input data, you have a corresponding output data. And second one is unsupervised, where we use for data exploration, and we apply for the clustering of the data based on similarities. And the third one is semi-supervised learning, which is like if we have some part of the data which is labeled and part of the data which is unlabeled. From the learning of the labeled data, we will segregate the other data and we will group it into the different groups. And the fourth one is reinforcement learning, which you see in actually any robotic applications, because it associated with some penalty and some reward for the action what it algorithm performs. And again, in the supervised machine learning, as we are applying supervised machine learning in most of our cases, my focus would be on supervised machine learning only. And in supervised machine learning, if you subclassify, then we have classification, that is, it's a discrete thing. Whether it is if you given a dog or cat, then it will say that okay, it's a cat, identify it as that is a discrete value. And regression, that is a continuous variable. If you see that regression means any prediction of any value, price of your car is an regression problem. Okay. And third one is probability estimation, whether a particular reader will read particular article in the paper. That's how much is the probability that you estimate there. This is what a supervised machine learning is. For every input data, you'll have corresponding output data, and the output would be the output would be then we teach to the algorithm, and algorithm will give a model as an output, which will use for further predictions. Means we use the training set data and we develop the algorithm and we get the hypothesis as an output. And if we for any new input, it will predict the output. This is how a supervised machine learning works. And further, the classification and the regression example, that here the classification is based on income and savings of a particular individual, that how the individual's credit score is, and based on that whether if a bank issues a loan to him, whether it is categorized, it will be high risk or low risk. This is the classification. You can see these are all like even though higher savings but the income is less, then he will be categorized as high risk. Similarly, that higher income, higher savings will be categorized as low risk. On the right hand side, you can see a regression problem, which is typically price of a used car, that based on the car attributes, like what is the mileage accumulation, how many number of owners, what is the type of transmission. You can see on any web page of this used car business, you can find all these attributes, and it predicts the price of that car. Again, as I said, like in the unsupervised machine learning, it is for majorly for the market research applications and data exploration, where you find patterns between the data points what you have. There are different techniques for doing that, and the ultimate output would be the groups in which they are categorized into based on the data. These are some of the popular machine learning techniques which I have listed here. And among these, the currently what generally which we can perceive is long short-term memory, which is an RNN technique, recurring neural networks technique. That in this, like it will deal with the sequence prediction problems. Here I have listed that one-to-many is an example of if you give an image, then it will write the caption for that image. That is one-to-many, because the input is one, whereas you are giving the output as an description or the caption for that image. And many-to-one, if you go and see on the web pages, there are reviews for the products. There are many paragraphs which they have written, okay, or many lines they review the product about, and whether it is a positive review or a negative review, how the impact would be, that will be decided. That is many-to-one. And many-to-many is a natural language processing example. That if I say something in English, then it will convert into Marathi or any other language. That is natural many-to-many examples. These are some of the domains and the applications of machine learning and artificial intelligence. You can see here the medicine, in the medicine field, that okay, now people are diagnosing different diseases based on the past data of the patients. At the same time, we are using computer vision in the automotive domain for the ADAS applications for identifying the objects in the particular scenario. That what objects those are, identifying a traffic sign board, identifying pedestrian, how the pedestrian is going to behave. All these this labeled data will give you as an output. The robot control, like, you know that people are developing robots to play soccer, and they are using them as an receptionists, okay, and to attend patients. Okay, and particularly in Canada, these applications are very high, where there is a higher aging population, that they are developing small pet, looks like a pet. The robot will support the people who are aged people who are suffering from dementia. And natural language processing, as I explained, that the applications are like, it will understand the review of a particular product, as it is a positive or negative, and it will also at the same time it will convert from one language to another language, and it will identify that the parts of speech of the particular language, okay, whether it is an adjective, adverb, what it is, and it will convert into different language. And it's also being used in finance, predicting the rise or fall of a stock. And the last application is like business intelligence, where we are business analysts generally use this for predicting a particular market area where it is going to grow and how it will be, the scenario will be. So like we understand that okay, there are different machine learning techniques which we develop, and how to evaluate them. Why we need to evaluate these learning algorithms? We need to evaluate the learning algorithms because we are predicting an outcome, means we are labeling it unlabeled data. Okay, that is why we need to understand that how the algorithm works, or what are the parameters which we need to consider, okay, for the performance evaluation, those things. So performance evaluation, generally we go with the absolute error, which is that the target outcome minus the actual value, okay, or the least square error, which we generally do in any of our statistical evaluations. And third one is like precision or recall, because that is like precision or recall is for the classification. If I'm giving showing an object to the algorithm, then how it is identifying. If I'm showing a cat picture, then how many times it is identifying it as cat correctly. Those are like deep neural network configurations which they use for the image recognition. And there are sampling methods also in this. We generally split the data, complete data into training data and testing data. And in the training also we have training and validation. In the validation we do a cross-fault validation to understand it in a better way, that if we have a complete original set data, imagine that there is a bread, okay, which is sliced. Okay, now the cross-fault validation, how it works is, for training what you'll do, you'll take one slice and train the algorithm. Similarly, next time when you are training, you'll not pick up the same slice, you'll pick up the different slice from the bread. Okay, and you just average out those model performances and evaluate the final performance of the model. At the same time, there are some issues with the machine learning model if you have not chosen the model correctly, if you don't have the sufficient data to train the model. These are some of the issues which I have listed here. That is underfitting. Means if the behavior is, I'm giving a simple example, that if you are predicting a stiffness of a spring, which is actually nonlinear in nature, but your hypothesis is linear. That is what y is called mx plus c, what your hypothesis is. Then in that case, then it will give an high bias value for that. At the same time, like if you are using an overfitting issue, then it is like you have the data points and again you are testing also with the same data points. So what it will learn is, like, it will learn the same point and it will memorize that point. If you give any small variation in that point, small perturbation in the point, then the variance will be very high. These are the issues with the machine learning model. And the other issue is, like, if you have characterized for a particular material, if you want to generalize that for other materials across the domain, then what are the assumptions you made for that material, whether you have considered those things or not. Those will also introduce some error into the model. So with that, the introduction, now I think like I can go to the engineering use cases, which I have, which we applied these machine learning techniques. Of course, I am not as a single individual applied these things. We have team for which we have worked out these areas. Is this okay so far?
Yes, sir.
Was I audible throughout?
Yes, it's audible.
Yeah. So we have applied like it's a prognostic approach. You can say that for the brake pad wear prediction, and second one is vacuum electric vehicle vacuum pump on-off strategy, and third one is an utility problem. It's not really an engineering case. Okay, it's like mode mix infotainment. It will identify the mood of the person, and it will play the songs from the playlist of his favorite. Okay. I'll just go to the brake pad wear prediction. See, any vehicle's core brake performance. Okay, it's like brake pad wear is one problem. Okay, which we can associate with. Okay, so but how the customer will know that when he has to change the brake pads? Okay, it's a difficult challenge. Okay, with that challenge, actually we started working. That if you can see on the left hand side, this is the test rig. We apply the we analyze the road load data. That is at the center of the slide. That we run the vehicle all over India in different terrains, okay, and we analyze that usage pattern of the customer. After that, we extract the damaging part from the road load data, and that data we simulate on the test rig. Okay, that is on the inertia brake dynamometer. You can see how a brake pad wear is being measured. We use a micrometer and we take average of all these points on a brake pad. Okay. And what's the other method we have? We have analytical method. okay, wherein we use finite element analysis for the brake pad wear, okay, and some empirical solutions we have for prediction of the or calculating the brake pad wear. Okay. So why we are choosing machine learning? Okay. One is the cost of physical tests and physical test time. Okay. To accumulate around 1 mm wear, we need to almost test for 3 weeks. Okay, that's how the test conditions would be. Okay. It is not that that we will get 1 mm wear or 2 mm wear. It's very easily, okay, on a test rig. Okay, that all the 3 shifts we need to work. That's why like it consumes a lot of time. Okay. And second thing is availability of the prototype vehicles. Okay, for if it is like a vehicle has to be driven all over, then also like around 50,000 kilometers we need to run. That's the life of the brake pad. Okay, and also another thing is like this wear is also dependent on the user behavior, how the driver is using the vehicle, and environmental conditions, how the temperatures are, ambient temperatures are. Okay, and the fifth reason is that these empirical solutions are not sufficient enough to calculate the wear exactly. Okay. And when it comes to finite element solutions, the material of the of course it is an homogeneous material. The mixture is homogeneous, but the material property is not characterized as the way it has to be, the brake pad material. Okay. That is why we are going for this machine learning. So before going to machine learning, we need to identify the influencing parameters. That is the feature selection. That what we have done is like we have devised the cycle that we kept one here. C means constant, V means variable. Okay, and these parameters we have devised, and these things are converted into a test specification, and we conducted the test, and we understood that okay, how the life of the brake pad and the initial speed, how they are influencing. Okay, wherever they are highly influencing, those parameters only we have considered. And the life of the brake pad is calculated using this formula. You can see here, it is that distance traveled multiplied by useful thickness by the total wear, what we observed. Because useful thickness will be around 10 mm at the start of the vehicle. If it's in new condition, what are the wear? Based on that, it will give us the life in terms of kilometers. This is the data. Actually, this is the normalized data. That again, our problem case falls under a supervised machine learning. That these are the parameters which we have considered. Where per actuation, initial speed, final speed, kinetic energy killed. Because ultimately in brake, the thing is like when you are applying brake means you are killing the kinetic energy of the vehicle, and which part of it get converted into heat. And the other thing actually which actually turns out to be the worn out parts because of the friction. So using these parameters, actually we started with a multivariate linear regression problem. We understood that the relationship is beyond a linear relationship among the influencing parameters, and we tried with support vector machine also. Even there also we are getting very less accuracy. Then we shifted to artificial neural networks. Artificial neural networks are actually inspired by the neuron of a human. Okay, how a neuron works in our brain. These networks are inspired from that. And here like we need to give the input parameters. We have input layer, we call it as, and there are hidden layers which we have generally we take 2 times of the input layer. Okay, the number of neurons in input layer, we take 2 times of that one, and there is an activation function and the output. What's the output? What you are expecting? In our case here, these are the input parameters: initial speed, final speed, kinetic energy, deceleration, and temperature. And the output is wear. Okay. Yeah. In artificial neural networks, we call a technique called back propagation. that initially that we go for a forward propagation, and then for improving the accuracy or minimizing the error, that we go and calculate these weights of each neuron in the back propagation. You can see the animation how it is working. Yeah. So after that, we have done a comparison of the models what we have used. We have used multivariate linear regression, support vector machine, artificial neural networks. And the correlation which we established with the road measurement, we got around plus or minus 2 microns is the error which we got from the field test and the model prediction. And the variation is around 250 kilometers, which in terms of kilometers, that is the life. And what are the benefits if we deploy this application? We can avoid physical tests for a particular brake pad material and selection of the brake pad material. Vehicle application dependent brake selection means whether that is for a tipper or a truck or an intracity vehicle, intercity vehicle, those kind of applications, or a car. Based on that, we can do that. Still, some work has to be done in this area, which we are still working. That is, we have already developed the initial temperature model that we have mentioned here, 1D simulation, but we have used again artificial neural networks only for identifying the initial temperature, because that information we cannot measure on the vehicle. It has its own physical constraints. Because the brake is a moving component where we cannot really put in a thermocouple and measure the temperature. And our ultimate aim is to indicate the user and give end user that an indication that this is the time you need to change your brake pads for better performance. I'm now shifting to my second case, that is EV electric vehicle vacuum pump on-off strategy. Was I audible so far?
Yes, audible, sir.
Yeah.
Yes, sir.
In braking system, actually, the brake booster will assist the user to apply the required amount of braking force. Okay. In electric vehicle, in IC engine, actually, the brake vacuum pump is being driven by the engine. Whereas in electric vehicle, we don't have an engine, so the electric pump is motor driven. So we cannot continuously run the vacuum pump. So we need to on it on and off. Okay, on it on, turn it on and turn it off whenever required. Okay. So the problem statement is that based on a given pattern, that usage pattern, that we need to say that, okay, if we need to always ensure, the challenge is that we need to always ensure that there is sufficient amount of vacuum is available for the end user, so that he can feel that comfort. At the same time, we need to maximize the life of the pump, as it is not being continuously driven by the engine, as in the case of IC engine. Okay. Here I am showing you the vacuum depletion curves. Actually, this is a lab experiments which we conducted. The bottom graph shows the pedal travel, that is for 20 mm, 30 mm, and 40 mm pedal travels, and the top graph shows the vacuum depletion. We put in a vacuum sensor, and we understand that how the vacuum is getting depleted when you are applying a brake at these many intervals. This data is being used. Okay, that is what RLDA data, that road load data acquisition data. And then now our challenge is to define a strategy where we can make it on or off, okay, based on the requirement. Now we need to come up with these two values, that where I need to switch off my vacuum pump, where I need to turn it on. Okay. This is the flow of the this is the workflow what we followed. Actually, we initially understood the depletion rate by applying different in a static condition and dynamic condition. We applied the brake. and we understood that how the vacuum is getting depleted, and we understood the pump characteristics, that if I switch it on for 2 minutes, like 2 minutes or 2 seconds or 30 seconds, in that range, that how much vacuum is being generated by the pump. So I know that how much depletion is happening, and I know how much generation is happening. So I can come up with an algorithm that, okay, if my pump is on for this many seconds, then this is the vacuum which I'll be having at hand for consumption. And I know the depletion rate which when I apply the brake, how it is happening. So I can characterize these two. That's what we have done. With that, actually, our aim is to identify the best pump operating range. That if I operate in this way, that okay, these many times if I need to switch it on, switch it off, then it should always ensure that my operator will get the required comfort level, and at the same time my pump will not get damaged, and it will give throughout the life of the vehicle. Here also we have again used the artificial neural networks. That's why I'm not showing anything there here. Okay. Here the major parameters are the pedal travel and the vacuum sensor, whatever the vacuum level, current vacuum level with respect to time. And what are the benefits here? Is the development time reduction, because I can for any other application, because I know already I have the road load data, how many times I applied the brake for a particular given stretch of data. So from that I can always extract the vacuum depletion and vacuum generation data from there, and that data I can use it, and I can come up with a strategy for operating the pump effectively and the most optimized way. Yeah, the third case is not really an engineering use case. Before that, I just want you to introduce. Introduce to you that what is artificial intelligence, because this is a deep neural network problem. That is, we have used convolutional neural network. Before that, I just want you to go through this video.
Hey, baby. Hey. To create avatars that can actually learn, interpret, and interact with the world around them, like a real human.
What's this? Spider. So we're starting to get a spider forming in her mind here. She's starting to associate the word with the image. So baby, spider. Spider.
Spider.
Good. Okay. What's this?
Spider.
No. This is a duck. Look at the duck.
Duck.
Yeah.
Baby X uses a type of AI called object recognition. Basically, it's how a computer sees. How it identifies an object like a spider, or tells the difference between a spider and a duck. It's something that you and I do naturally. But machines like Baby X need to learn from scratch by basically sifting through enormous piles of data to search for patterns, so that eventually it can drive a car or pick out a criminal in a crowded photograph, or tell the difference between me and that guy.
But now I'm going to tell her the spiders are scary. Look out! Wah, scary spider! Rah. Hey, don't cry. It's okay. Hey, it's okay. Now she's responding emotionally to me as well. So we've gone all the way down to virtual neurotransmitters, hormones, and so forth. So
It is Baby X from Solve Machines. Was the audio audible of the video?
Yes, audible.
Was it smooth or is it breaking?
No, it was very smooth.
Yeah. You can watch these videos from Age of AI on YouTube. There's a web series about application of artificial intelligence. Because I found it interesting, that's why I'm sharing with you. So the problem statement which we have taken is here, the mode mix infotainment. Can we shuffle the songs based on the person who is driving? So it's started from there actually, and there are images available for identification of the mode that we have used Kaggle data set from Kaggle. and we have used Python and Python as our programming language, and the technique which we used is convolution neural network. I'll just introduce to you that what convolution neural network is. This is the workflow. Actually, it starts with the driver capturing the driver profile of the particular vehicle owner. That is that we will try to understand his likes and dislikes, what kind of music he listens to generally, those things. After that, we'll capture the image, and it can identify happy, sad, anger, fear, and the neutral. After that, once it identifies the emotion, then it will start playing the song from the playlist what is already there, the back, or it can be linked to any what you call music platforms, like any Amazon Prime Music or Ghana, whatever it is, like you can integrate with. After that, once it start playing the song, when the track is completed, then again it will start detecting. If it continues to be in same mode, then it will continue playing that. It will ask the user, shall I continue play that same playlist, or do you want me to change? Otherwise, it will change according to the, at any given point of time, the user can override all these things. So what is CNN? How it is different from artificial neural network? So they look similar to artificial neural network. Only thing is we will have some convolution filters to actually identify the features of the image in detail. So for an example, this is a big detector. This is a convolution filter applied to an image. That you identify the beak of a bird from the photo. Okay, from the image. Okay. So this is how actually, if you can see that, okay, Facebook how actually completely developed based on this logic only. Entire Facebook, apart from other algorithms. Okay, what I'm saying is particularly for the face tagging, those algorithms. So this is how a deep neural network looks like. If I'm giving a car image, then we'll apply a convolution filter. Okay, these are like processing for max pooling, the pooling processes. After that, it's a fully converted network. There's again here it's a ANN network only simply, and then softmax activation function, which will identify the mood of the person or the user. But how it will understand actually from an image? These algorithms, how they understand? They understand very low level features, which are like lines, okay, and slanting lines, horizontal lines, those lines. After that, it will start identifying the patterns in that. Again a high level features in that. That's how it will actually classify an image, particular image. That if you are aware that, okay, there are many algorithms, there is a competition which actually happens between these algorithms, that how fast they are performing. That information actually not available with me to present with you, but I can share with you based on your interest, the thing. So if I give you an cat, the same representation in a flowchart, that how it works, that okay, we apply a max pooling, again a convolution, max pooling, that this can be as deep as possible. Okay, these things. Okay. So this is a small setup of ours, that what we have done. What we have used Raspberry Pi with a camera, and the purpose is that, okay, it'll just identify the mood of the person, and based on his mood we categorize the music also accordingly. Based on that, it will go and start playing the playlist. This is the video demonstrating that algorithm, it is working. This is the algorithm what we worked and deployed on Raspberry Pi.
You seem happy today. Here's a song for you. The
चला जाता हूँ किसी की धुन में धड़कते दिल के तराने लिए चला जाता हूँ किसी की धुन में धड़कते दिल के तराने लिए
That's it from my side. Thank you. Thanks for having me here. If you have any questions. Hello.
Hello, sir.
Yeah, if you have any questions, then I'm happy to answer.
Sir, I would like to ask, how was your experience working in Tata Motors?
See, Tata Motors is a company where you will get a chance to explore new things. Okay, it's my first company. Okay, so I don't have exposure to other corporates, but what I can tell you is like here get a chance to explore new things. They'll give that freedom to explore new things.
Okay, sir. Thank you, sir.
Anything else? Anything on the presentation? See, you should have a strong mathematical knowledge if you are going to develop a new algorithm. Okay, that is one area which we need to improve a lot if you are developing algorithm. Okay, where there are many softwares. Okay, software tools available now often that okay we can directly implement those things, but you should have that mathematical background to understand that how to evaluate a particular algorithm and its effectiveness. Any more questions?
Anyone with any questions on the topic?
I mean, was it audible throughout?
Yes, sir. Yes, sir. It was audible. Sir, yeah. Anyone with the questions? Okay, sir, how like I just wanted to know like since it is been AI, everyone are talking about AI ML. So how advanced or like how much we can like as a mechanical engineer, what we can expect from AI ML? Like what is the scope for the upcoming engineers?
Yeah. See, there are many applications now coming up. Okay, even into the design, even in the CAD model also. Okay, if you given the boundary conditions, then the AML is going to transform the algorithms are to the extent that okay they're creating an optimized structure. Okay, you considering the finite element analysis impacts also. Okay, while creating the design itself. Okay, to that extent, actually AML is being used. Okay, in the and from the utility side, there is no limit as such. Okay, you can
Okay.
see you can feel that from your mobile, right? When you are typing something, then it is giving suggestions, right?
Yes, yes.
So that is based on RNN, okay, recurrent neural networks. Okay,
Okay.
so it will understand and natural language processing. From that, it is giving you the suggestions that okay, what is that next word? Okay, you can see in the mails also, Outlook also. Some of them they are already deployed, and Microsoft Outlook also. Okay, and
Yes, yes, yes.
sometimes Gmail also they have already deployed some of them.
Yes.
So it's going to disrupt everything that okay this AML field particularly. Okay. But the only constant is you should have the quality data. Okay, because all these are like mathematical induction based, okay, mathematical formulation based. So If the data what you are inputting is not correct or sufficient enough, then you'll end up in having an incorrect result out here.
Okay. Okay, sir. Yeah. So Harsh, I guess there are no more questions from the audience. You can carry on with the further.
Yes,
Harsh,
sir.
Shlok, yeah.
Thank you very much. Thanks for having me on this.
Yes, sir. Yeah. Thank you, Harsh. So guys, this is the first time I'm having the interaction with your student chapter. As you all may be aware that I'm the young member chair for India branch, and so the reason of me talking today with you people is just to inform you that there are many opportunities with IMechE where you can try to gain knowledge, or just try to go to our website and see like what are the things available. So if you are in your final year of your graduation or course, so or maybe if you are in second year, third year, even you can utilize that, where you can get the research papers, journals just for free, a library, complete digital library from IMechE, which is completely free for all of us. And the same papers, if you're trying to get it from Science Direct, okay, you have to pay a fees of like $10, $15, depending upon the paper. So I would suggest you people to utilize the resources, utilize the get the opportunity, because opportunity gets you one time. It will not knock the door every time. And coming to the opportunities, IMechE has, I guess you are already aware, or most of them they may not be knowing about it, that IMechE has multiple competitions across. We are hosting national competitions, and IMechE from UK, they are hosting international competitions. Recently, we had international technical paper competition, which almost I guess 3 to 4 people from India had participated, and results are yet to out. So you just had to write the paper, a technical paper on a topic which they have given, and you could win almost like 20 to 30,000 rupees of Indian rupees, Indian INR rupees. So such kind of competition where you just have to do. And so talking about the competitions, the upcoming competitions, which is my main focus, is we are about to start Sophie Speak Out for Engineering 2022 this year, maybe by July or August. So get prepared, start preparing yourself. And if you are not aware about what this competition is, you can get back to me on the same anytime. Or you can get my number from Harsh or maybe Shlok, or the committee members. And the criteria for this, and it's an international competition. The winner from India will be competing with Bangladesh and Sri Lanka, and the winner from there, he will get an opportunity, complete air travel, visa and stay facilities completely available at UK. He will be getting a trip to UK, attend the event and come back. And let me just tell you, 2021 Sophie is the final SAR, that is India, Bangladesh, Sri Lanka. Event will be happening next week, that is on 26th of June, and the winner will be going to UK this year. So it's a big opportunity, and the winner from India will be getting a prize money of almost like 20 to 25,000 rupees. And let me just tell you that this competition will check your skills, not the content. The content has only 10 marks out of 100, and the way you prepare, the way you present yourself, that gives you 90 marks. So it's a big opportunity, grab it. That is one competition which we have upcoming. There is another global engineering debate which will be upcoming in maybe by October or November, and the dates details will be shared whenever it is out. And there are other national level competitions which are only for India, that is photography competition. I would suggest everyone to participate in this. There will be a theme, just based on the theme you have to take a picture and write a caption, a brief about it, and then send it to us. And you can win almost like 5,000 to 10,000. I don't know what will be the prize money this year, but almost like 5,000 to 10,000 rupees you can just win. And these are the competitions which we are planning, and there are many other competitions. So to know about this, get in touch with IMechE India branch and Young Member Panel India branch, and we'll be providing you the assistance. And also I would like to request the committee members to host such webinars events every at least two bi-weekly, or at least two webinars or technical lectures, two in a month, so that it is people can learn new things rather than just sticking to our notebooks. Okay, so that's all from me as for today. If there's anything you would like to ask me, I'm open for it. Any questions, anything for discussion, please be feel free to ask any questions. Anyone? Harsh, Shlok,
Yes.
you're on mute. So if anyone wants to ask, you please unmute yourself and you can ask. Okay. I guess that's all from my side. Shlok, you can continue ahead.
Good morning, everyone. I extend my gratitude towards Mr. Dattatreyudu Mullapudi for such a thought-provoking session. Special thanks to Mohammad Amin sir, Young Member Chairperson of India, for guiding us and organizing this webinar. On behalf of IMechE Student Chapter MEJ, I extend my thanks to Honorable Professor G.K. Prabhu sir, President Manipal University, Jaipur. I would also like to give my gratitude to respected Registrar MEJ for providing us unconditional support for smooth conduction of this webinar. Also, cordial thanks to Professor Ashish Goyal sir, Mechanical Department, Faculty Coordinator of IMechE Student Chapter MEJ, for being a part of this initiative. I acknowledge the contribution of the media team. I would be grateful to each and every contributor who made this event a success. I would also like to thank Young Members Panel India Branch, Automotive Division, India Technical Center, IMechE India Branch for providing us with the opportunity to conduct this webinar. I would also like to thank the members of SAR for joining us in today's session. I would also like to thank IMechE Student Chapter, and above all, I would like to thank our enthusiastic audience, especially the youth of this nation, since they would be the change in society. Thank you, everyone.
Thank you, Yash. Thank you, Shlok. Thank you, Harsh.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you very much from Sri Lanka. It is very well presented. We really like the way it has been conducted. Thank you.
Thank you, sir.